All right, everybody, what's popping? So we are getting towards the end of class here. One of the sort of like baseline tasks we'd like you to at least have sort of a passing familiarity with when you leave R Davis is dealing with dates in R. Obviously, any number of data and research and analysis applications where you might have to deal with dates, and they're sort of famously or infamously a bit tricky to deal with. We talked, for instance, way back in week 1 about how Excel does terrible things with dates. R is a little better, but there are some tricks. In particular, we're going to talk about the Lubridate package, which is a great name, easy to remember for dealing with dates, and also just sort of unpack a little bit of what's going on under the hood. Probably sort of the high level complication here is that we've talked about different sort of object classes. So characters, numbers, factors, that type of thing. Date objects are like a subversion of those. So R can have things that are encoded as date objects that have certain properties, right? It's looking for sort of month, day, year, that type of thing. So you might start by reading in, say, a column of dates that R treats as a character or a factor. And so it's just like, a set of strings, right? It's like 3-21-2021 or something like that. And R doesn't inherently know that's a date. It thinks that's a factor or a character. And so what we're ultimately talking about is how to tell R, hey, this is a date, and to encode it so R not only knows it's a date, but it has the correct date. So let's jump into that. So if you've looked at the module for this week, you've seen an overview of sort of like date time classes that exist in base R. So there's like just a date, right? And that's a pretty straightforward one that you're used to seeing, like year, month, day. And that is actually something to be aware of. It's sort of like the base encoding of a date in R is year, month, day, rather than day, month, year, or whatever we might do sort of colloquially. And then there's these two weird categories, POSIX CT and POSIX IT. And I totally don't remember what POSIX stands for, but as like a rule of thumb, if you see POSIX, you know that you're doing something to do with dates and times, right? And so it's like date time land. I saw POSIX. The CT stands for calendar time. The LT stands for local time. In general, we're not going to spend too much time on that because the dealing with dates and times in base R is not a lot of fun, which is why Hadley Wickham and the Tidyverse crew made the Lubridate package. So let's try a couple things here. So I'm just going to copy and paste this vector of sample dates from the learning module for this week. So we can take a look at that. If we str on this vector called sample underscore dates underscore 1, and R says, hey, this is a character vector that is 5 units long. It doesn't know it's a date. We can't really order it. If we tried to sort it, it would sort, but it would sort as if it was alphabetical. And so we would get 2018 first, all the way then to 2019. And it actually like accidentally corrects itself in terms of like the furthest away to the most recent, because we read it in correctly as sort of like a year, month, day order. But it's sort of this luck of the draw, right? And so with that, R doesn't know it's a date. It just sort of works because this was encoded in the year, month, day order. All right, so the first thing we might want to try is simply use a base R function called as.date. And sometimes before I even code an object, I like to just run the function and see what happens in the output. In this case, nothing happened because we called as.date and R looked at it and said, oh, this is the format I expect it to be in, and it generated a date object, but it actually looks the same, right? Because we read it in correctly. It was specified correctly when we read it in the first time. So again, we're sort of dealing in lucky land right here. But if we look at this object, sample dates 1, now that we've converted it to date, it looks the same. But if we call str on this, now we see that instead of a character vector, it is a date vector, but other than that, it looks the same, but R understands that it is a date object. Okay, so the second example we showed you in this module is the unlucky version. And so what happened here is this vector of dates are stored in month, day, year format. So you can already think, like, if you call sort on dates encoded this way, it's going to sort in terms of month and then day and then year if it's just sort of working alphabetically or numerically. And so rather than actually sorting in terms of the actual temporal sequence, you're going to get all the Januaries, then all the Februaries, then all the Marches, that sort of thing. And sure enough, if we read this object in and we call as date on this type of object, let's go ahead and take a look here. Oh, my scrolling's broken. Oh, there we go. Sample underscore dates underscore 3. Oh, that looks terrible. So we have, looks like the year 2 AD, looks like the year 10 AD, looks like the year 1 AD, and a couple of NAs that quite simply failed the process. Okay, so we obviously know this didn't work, and this is where things like Lubridate come in, or the hard way, and that's what we'll show you first so you can appreciate Lubridate. I always forget we sometimes do the hard way and then go for it. So even in base R, there's this functionality that you can read in dates in whatever format, and then you can actually tell the function, here's how these dates are encoded. And so essentially this type of conversion, so we've done things before where like we had as numeric and we just said convert it to character. As date, there's sort of two things to be aware of. So one, the vector you want to turn into a date, and then two, you can actually sort of hand specify, here's how this column of dates is organized. And so that's what's going on in our example code, is we have our sample dates to vector that is stored in month-day-year format. And what we're actually going to do is when we call as dates on that vector, then there's going to be a second argument to the function, and that function is going to be shorthand for how the date is organized. And so if you want to learn more about how to do that, you can call the question mark on as.date, the function, and got to expand this window here so that shows up. And in this help file, there's lots of information. And the most important one is, as you scan down, is it starts to give you some indication of how to actually specify like the shorthand version. So in this case, it's pretty easy, right? The %m dash %d dash % capital Y. The capitals have a special meaning in terms of whether it's a 4-digit or 2-digit. There's different ways, and we'll show you an example. So like, let's say you have month as word rather than month as number, things like that. So all different shorthands for representing. But in any case, what you're specifying here is how the different pieces fit together to make a coherent date. So in this case, right, you have to specify the dashes, but you could envision, for instance, if it was just spaces in between, then you'd leave spaces between the M, the D, and the Y. Any number of ways you can specify this. But the point is, if we run that, we end up with actual dates again. So we can try a few different things, right? So let's see what happens if I use lowercase y, and that didn't work. And so that's an example. See, the uppercase, the lowercase, these different codes have a special meaning in terms of how it's processing things. And so the lowercase y, it's looking, so what happened here is it's looking for the first 2 digits of year. And since it's 2018, 2018, 2018, 2019, 2020, it looked at the 20 and it thought, oh, this is the year 2020. And so that produced the incorrect dates. And so couple things to take note of there. You not only have to make sure R is aware of the format your date's in, but you have to make sure you use the right special characters and special code to denote the format. And like this is a case that it looks almost right? That converted the dates from 2019 to 2020, and you might not totally be aware, particularly if you had multiple, if you had 2020 dates as well in your data set, you might not notice this the first time. So you want to make sure you get the code right. A way I typically do that is I'll make a subset of my dates, just a quick little vector, and I will call as date on that, or the right Lubridate package. I will actually line them up and say like, oh, these got coded, like these 5 got coded correctly. And at least then I kind of know I'm off to a good start. And so even when you get pretty good at R and pretty good at these packages, you want to make sure you're not sort of taking that for granted and just running it all without ever taking a look. Like pull a couple of the dates, run them through your code that you've developed, make sure it actually does the right thing. Because even those small tweaks, right, I just showed you, if you forgot and did lowercase y instead of uppercase y, it totally blows the formatting and you end up with the wrong dates. Okay, so I'm going to let you try the challenge on your own. You can also be aware that R handles times as well, and so you'll see sometimes like R will actually have like a date and time together, right? Dates sort of like longhand for time. Times are a little trickier to work with. I'm not going to spend too much time, if you will, on this because essentially what we're getting into is just like more of formatting details, right? So if you looked at the lesson here, the example code for conversion, right? We not only have like a date and time, so now you have to specify a whole bunch more percentage times and percentage signs and shorthand. So we have like the DMY. Now you have an H for hour, an M for minute, an S for second. That stuff all gets pretty complicated. And so I will leave that for now. I think my general assumption is that if you can gain facility dealing with dates, the way our approach is time is just sort of a follow on from that. It's just sort of added complication. So I think as sort of a baseline goal, if you can be comfortable reading in dates, converting dates, I'm pretty confident you'll be able to figure out time as well when that comes. And typically dates tend to be the primary source of heartache. Most of us don't have a ton of stuff that's like ultimately time sensitive. Okay, so that's all well and good. Now we want to show you the Lubridate package, which is a little bit nicer way of dealing with all this. So as always, you're going to install that package if you haven't already. So install.packages Lubridate, Lubridate. Take my computer a second to do this here. Load the package, library Lubridate. Okay, it gives us a couple warning signs that it says masked, can't say that word apparently, from package base. So what that means is there's a function called date in the base package, and now there's a function called date in Lubridate, and so the Lubridate version is going to supersede it. That's okay for now. Okay, let's take our same sample dates package and show you some cool stuff Lubridate does. So Lubridate, essentially the most common thing most of us use Lubridate for is they have hardwired some conversion functions. So you don't actually have to specify the formatting and think about like, oh, you know, the lowercase d, uppercase d, that sort of thing. And so in this case, you can look at the vector we made and you can see it's in year, month, day format. And it turns out Lubridate has a function called year, month, day, YMD. And actually you can see, or you can read if you use the tab complete function here, it also has the time equivalence to that. So if you have time, it has YMD hour, YMD hour minute, YMD hour second. We just need YMD right now. And so essentially what happens here is you feed in your vector of objects in year, month, date format, and Lubridate is smart enough, it has some things wired under the hood that it just processes that. You didn't have to say, oh, it's a 4-digit year or a 2-digit year. It was just smart enough to say, oh, they said this was the year that came first. These years are 4-digit, so it must be a 4-digit year type object, reads it in correctly. You can reverse that, right? So let's say you had it in month, day, year format, MDY. This obviously won't work if we call it. Failed to parse, no formats found, it broke. But, right, so you can see we have a lot of flexibility here. And there's a day, month, year, right? So any of these combinations, YMD, MDY, any order of these three, it will read in. So that typically works. It has similar functionality with time zones. And again, I think this video is already getting plenty long, so I'm going to go ahead and skip over those. A couple other things I want you to be aware of. Lubridate has a couple other nice functions. It has a function called decimal date. Obviously, we don't typically think, oh, I didn't like that. I forgot to call YMD. Lubridate has to have, you feed in a character, sorry, you have to convert before you can call the other things. So the mistake I made there is I just called in that character vector again, and I had not made it a date object. And so then I called a function like decimal date on a character, and it said, I don't know what the heck this is. This isn't a date. What are you doing? So I had to convert it to a date and then call decimal date. So what decimal date did here is now we have like 2018.085. And so it actually is like the decimal representation of where these dates are in a given year. This is often what I use in sort of a break in case of emergency. If I just want to make sure things are perfectly sorted, if I'm like computing durations, or I want to covariate in my model that's something like time since 2017 or something like that. You can do addition and subtraction with dates in Lubridate and in base R. You can say like, take this date minus month 1, but I think it's much simpler to do decimal dates and work with that. But just to kind of prove to you, you can do it the other way. So here we have our date objects, and you can actually say subtract month 1, and we have that same set of objects that is 1 month prior. Or you can do actually, oh, weird. Something happened there. You can then subtract year 1. Oh, I didn't like that. Anyways, something's broken there. I should look into that more, figure out what I did wrong, or maybe you can already recognize what I did wrong. But in any case, right, so that I think is a lot jankier than using something like decimal date, and then you can always convert back. So if this is decimals, then you can call date decimal on your decimals, and it will convert it back into a date object. And you can see actually now it added time, which we may or may not want. So you might end up dropping that off. Anyways, I'm sort of rambling at this point, so I should go ahead and sign off. Please take a look at the rest of this module. I didn't cover everything because I want you to have a chance to play with some things. You can look at the time zones, some of the other parsing features. The other thing to take note of is we have a little bit of material about reading in dates and how Lubridate can work with the tidyverse to process dates as you read them in. Recall that the read_CSV function is always trying to guess the content of different columns. And so just kind of be aware that it might guess right the first time, it might totally guess wrong. And so you want to kind of be aware of when and how you have to process dates. And you can sometimes, what the showed up in the example code is that rather than converting on the back end, sometimes you can actually specify like a column type, and you can say, hey, this is actually a date type column, and it will process that when it reads it in. Sometimes that's more work than it's worth. Anyways, thanks. Let us know if you have questions, and have fun with Lubridate.